Hello and welcome back to this week's episode of ABI Labs. So far we have been covering how we can use the BoardMaster to test analog ICs in circuit as well as discrete components. In the previous episode, Oliver showed us how we can use the BoardMaster to test quad differential amplifier, the LM324, as well as the LM339, which was a competitor. He also explained to us how the system, depending on the device, carries out a different test technique. So in this episode, we will be looking at the MIS4, which is a multiple instrument station. So Oliver, can you explain the MIS4 to us?
Yes, of course. So the MIS4 is our module for all the traditional instruments. So in this 5¼ inch bay, you've got 8 instruments. You've got your oscilloscope, arbitrary waveform generator, your frequency counter, your voltmeter, ammeter, ohm meter, and you've got your auxiliary power supply, and you've also got your universal I/O, all in the 5¼ inch bay. So if you think of all those instruments spread out across your desk, it'd be from tail to end of our desk here, but instead we've got just one BoardMaster and one bay of all those in.
I can see how that could save someone a lot of time. Rather than having multiple instruments, different oscilloscopes, multimeters and so on, we have it all in one compact solution, allowing us to save a lot of time.
Absolutely. So all those instruments are in the software. You don't have to go find them spread across your office. They're all in one module. All the settings are saved in the software, so you don't need to tinker your oscilloscope every time you turn it on. And you can use all those instruments all at once. So you can use your oscilloscopes and your multimeters and your frequency counters all at once.
Oliver, can you show us the instruments in the software?
Absolutely. So in this step of our test flow, I'll open up the oscilloscope. There it is. It's got 3 channels. It's very similar to all the instruments you know, and unlike other products, it's all built in, so you don't need to create your instrument from scratch. You can just open the instrument and you've got your oscilloscope from the get-go. We've got 3 channels, as I mentioned, and you can also store a mask. So when you measure your signal, you can then click Save and Store, and it'll store that mask that you can then compare against later. We're a big fan of pass and fail, so when you probe that mark again, it'll either give you a match or not a match, a pass or a fail. So that's our oscilloscope. We've also got our waveform generator, which has 2 channels. It's preloaded with a load of different sort of waves that you can use. You can also load your own file. One of our favorites is an ESG signal, where it's got someone's heartbeat that you can change the frequency, change the BPM, and you can also change the amplitude of that wave.
So Oliver, what are we testing here?
So on this board, we're testing a dual optocoupler, and specifically we're testing the propagation delay. We're checking that it actually switches on time and it hasn't aged at all.
I see. So why are we doing this particular test?
We're doing this particular test. We had a customer in South America, a railway company, and their trains, their fleet were being affected by the 40 optocouplers on one of their PCBs. So to repair that in the first place, they would have had to replace all 40 optocouplers, but now they're just using the propagation delay test to check which ones specifically need changing.
So they were carrying out a functional test first, and then they started using the MIS4 to test the propagation delay of the optocoupler.
Exactly, so they were doing full complete coverage of their PCB to make sure there was no stone unturned.
I see. So as you can see here, we're using 3 different instruments from the MIS4 at the same time. And with the oscilloscope, we can see that the switching speed of our device is approximately 8 microseconds.
Exactly. So this is a fresh PCB with a brand new optocoupler. So it's switching at about 8 microseconds. In the future, this might get delayed from age to about 15 microseconds.
And with the benefit of the mask, we obviously have a pass here because our optocoupler is working as it should be.
Exactly. So that mask is saved, and from each one of these PCBs, we check a new one, check a new one, check a new one. We can see if it's switching on time.
And you may have also noticed the universal I/O in the corner. We will be covering this instrument in more detail in next week's episode, so stay tuned for that.